Hello everyone, welcome to Content Hub. Today we'll be dealing with subtropical anticyclones, alternatively known as high pressure cells. Now we have three high pressure cells or anticyclones that are playing a crucial role in the weather of our country, South Africa. These high pressure cells, two of them are located on either coast of our country and the other one is located over the interior. Now please stay tuned and let us dive into the characteristics of these anticyclones. Our anticyclones, the high pressure cells, these cells, they are associated with sinking air that produces clear skies and no rainfall. Our anticyclones, they are also associated with anticyclonic air circulation in the southern hemisphere. The air circulates in an anti-clockwise direction in the southern hemisphere. Now, since we said that we have three high pressure systems that are influencing the weather of our country, we need to understand their location and what is their influence on this beautiful country. So let us start. What is the name of the anticyclone found on the west coast of our country? This anticyclone or this high pressure system, we refer to it as the South Atlantic high pressure cell. It is the South Atlantic high pressure cell. Now, this high pressure cell, it gets its name, the South Atlantic high pressure cell, because this high pressure cell is found on top of the Atlantic Ocean. Now, the Atlantic Ocean, it is a cold ocean or consists of cold waters, mainly because of the ocean current. So what is the name of the ocean current where the South Atlantic high pressure is found? The name of this ocean current that is found over the Atlantic Ocean, we refer to it as the cold Benguela current. Now, the cold Benguela current, this is a body of water that is stemming all the way from the South Pole, bringing all those cold conditions to try and maintain the balance over the areas that are found closer to the equator. Hence, the South Atlantic high pressure will bring the cold conditions over the interior. But then we also have a high pressure cell that is found over the Indian Ocean. As a result, the name of this high pressure cell is going to be the South Indian high pressure. The South Indian high pressure. The name Indian comes because this high pressure cell is found over the Indian Ocean. Now, unlike the South Atlantic high pressure, the influence that comes from the South Indian high pressure is very different from the one coming from the South Atlantic high pressure. The South Atlantic brings cold conditions over the interior, but the South Indian high pressure will bring the warm, moist air over the interior. The main reason for this difference that the South Indian high pressure brings the warm moist air, it is due to the ocean current that is also found on the east coast of our country. We have a ocean current that stems all the way from the equatorial region. Now remember that the equatorial region, it is the warmest place on earth. As a result, this body of water that is found around the equatorial region will also take the temperatures of that area and then brings them along the east coast of our country to try and maintain the balance over this eastern half of the country. So we have the warm Mozambique current. We have the warm Mozambique current on the east coast. And on the west coast, we are having the cold Benguela current. Now, because of these two ocean currents, the influence coming from the South Atlantic high pressure and the South Indian high pressure will differ. Now, firstly, let us look at the South Atlantic high pressure and study its influence over the weather of our country. The South Atlantic high pressure. Remember that the air circulates in an anti-clockwise direction in the west coast of our country. Now, as the air circulates around this cold ocean in an anti-clockwise direction, eventually that air that is found above the Atlantic Ocean that is influenced by the cold Benguela current reaches its or finds its way to reach the interior. Now, the air that finds its way to reach the interior, it is the cold, dry air. It is the cold, dry air. Remember that the air that is cold cannot hold more moisture. And you have to describe the air that reaches the interior from the South Atlantic high pressure. You need to put it in a way that this air, it comes from the southwesterly direction. So these are southwesterly winds that are cold and dry. Now, this southwesterly cold dry air, as it reaches the interior, it brings a different type of precipitation. Now, the precipitation that will be experienced along the west coast, it's not going to be rainfall, but mostly it is going to be fog or it is going to be mist. The one that is brought upon by the South Atlantic high pressure, since the air that comes from the west coast will be cold and will be dry. Therefore, we are going to have fog or mist as a source of precipitation on the west coast. Now, importantly, the South Atlantic high pressure can undergo what we call ridging. But what is ridging? You need to understand. Because when you are looking at the synoptic weather map, you will see your isobars that are around the high pressure cell. Now, when your isobars around a high pressure cell are elongated, when the isobars are elongated away from a region of high pressure, we say the process that is occurring there is ridging. Let me show you how. You are having a region of high pressure on a synoptic weather map. You are having an isobar followed by another isobar and another isobar. But when you look at this side of the isobars, they are more like extending towards the land. So the process that is occurring here, we say that ridging is taking place. This ridging that is taking place, what happens is that since the isobars are elongating away from a high pressure cell and the air circulates in an anti-clockwise direction, means that the air will circulate in an anti-clockwise direction and will now have a larger fetch. So it comes all the way closer to the Indian Ocean, where now the type of an air mass that is found over this side is different from the one that is found over this side. Remember, on this side, we are having the cold, dry air. But on the eastern half of this country, we are now having the warm Mozambique current. And this water on the eastern half is warm. As a result, due to this region that is occurring from the South Atlantic high pressure, this warm air that is found on top of the Indian Ocean will now be diverted towards the land by this anticyclonic circulation from the South Atlantic high pressure. When it sends out a tongue or when it elongates and it extends now the circulation of air away from a high pressure cell, this anticyclonic circulation of air will now divert the warm air that is found on top of the warm Indian Ocean, and it will divert it towards the country. Now, when it diverts it towards the country, now remember that the air that is now diverted on the southeast half of the country is no longer the cold, dry air, but rather the air that will be diverted here will now be warm air. This warm air will now reach the interior, will start to rise, cool down, condense, and it will now start to bring more rainfall on the southern east part of the country. But this will only happen when the South Atlantic high pressure is ridging. And this region mainly occurs during a summer season. It occurs mainly during the summer season. But now let us look in contrast. How does the South Indian high pressure compares to the South Atlantic high pressure. The South Indian high pressure, which is now located on the eastern half of the country. This one is influenced by the warm Mozambique current. Therefore, as the air circulates in an anti-clockwise direction, coming from northeasterly direction, this air will now reach the interior, and the air that will be sent, the air that will now be sent towards the land will not be cold and dry, but rather it is going to be the warm, moist air. It is now going to be the warm, moist air. Hence, the eastern half of this country receives more rainfall. More rainfall due to the influence of the South Indian high pressure that is feeding more moisture and more warm air to the eastern half of the country. And as a result, we are having more rainfall on the eastern half of the country. The people of KZN can attest to this. But let us move on. Now, our South Indian high pressure. Sometimes it can be referred to as the blocking high. It can be referred to as the blocking high. What do we mean when we say that the South Indian high pressure can act as a blocking high? It is a blocking high whenever it is found in the path of the approaching mid-latitude cyclone. When the South Indian high pressure is directly in front of an approaching mid-latitude cyclone, it is going to block the natural path of the mid-latitude cyclone. Remember that the mid-latitude cyclone, the general direction, it is from west to east. And with the anticyclonic circulation of air from the South Indian high pressure, the air circulates in an anti-clockwise direction. And our mid-latitude cyclone moves in an eastward direction from west to east. But now, because of this anticyclonic circulation, our mid-latitude cyclone will temporarily change its direction. Rather than moving from west to east, it is now going to move further towards the southern east. It is going to move in a southeast direction. Why does it move in a southeast direction? It is because it is diverted away from its path due to this anti-clockwise circulation from the South Indian high pressure. But our mid-latitude cyclone, it's not going to continue to move in a southeasterly direction forever. It is going to move in a southeasterly direction until such a time it regains its path again and move further eastwards. This is when we are no longer having a strong influence from the anticyclonic circulation from the South Indian high pressure. Now, when this happens, when we find the South Indian high pressure in the direct path of an approaching mid-latitude cyclone, and this mid-latitude cyclone is going to be diverted away from its path, we say that in this instance, the South Indian high pressure, it is acting as what we call the blocking high. Now, we have only spoken about the two anticyclones on either coast. We have spoken about the South Atlantic high pressure that is found on the Atlantic Ocean, influenced by the cold Benguela current. And we have just spoken about the South Indian high pressure that is found on the Indian Ocean, influenced by the warm Mozambique current. We also have the third anticyclone that changes its position over the interior. The name of this third anticyclonic circulation, anticyclone that is found over the interior of the country, we refer to this anticyclone as the Kalahari high pressure. Now, the Kalahari high pressure, it is a high pressure cell that is dominant in winter. Therefore, the influence of the sinking air that is coming from the Kalahari high pressure cell will be determined by the seasons. Now, the position of this Kalahari high pressure cell, as the seasons changes, it is going to influence what we call the inversion layer. Now, the inversion layer will also change its position during summer and during winter. Let us look at how the position of the inversion layer is going to change and what is an inversion layer. Let us look at these two diagrams of mine, showing you a summer season and a winter season. These red markings that I have highlighted here will represent the inversion layer. But firstly, let us determine what is an inversion layer. Your inversion layer, it is a layer in the atmosphere where temperature inversion takes place. What do we mean by temperature inversion? Temperature inversion, it means that under the normal circumstances, we will know that the higher you go, the colder it becomes. But with temperature inversion, we are inverting the normal knowledge. So therefore, in this layer in the atmosphere where temperature inversion is taking place, we are going to have a layer in the atmosphere whereby temperature increases with an increase in altitude. What does it mean? It means that in this portion of the atmosphere, the higher you go in this portion of the atmosphere, the warmer it becomes. The higher you go in this layer in the atmosphere, the warmer it becomes. So how do we end with this inversion layer in the atmosphere? Let us talk about the formation of an inversion layer firstly, before we go on to the position of the inversion layer in summer and in winter. As the air rises from the land, as the air rises from the land, remember that the air as it rises, it cools down. Now, the air that will rise from the land, closer to the land, it is warm. So as it rises, it becomes cold. As it rises, it becomes cold. But the air that is sinking from higher in the atmosphere, it is cold. So as it sinks, it undergoes what we call adiabatic heating. It undergoes what we call adiabatic heating to say that as this air sinks, it gets warmer. As this air sinks, it gets warmer. Now, there is a position in the atmosphere whereby you are going to have this cold air that is trying to rise and this warm air that is sinking. So, this position where this warm air that is getting warmed up adiabatically gets trapped between the cold air that has cooled down as it rises and the cold air higher in the atmosphere. So you are having this region of warm air in between the two air masses of cold air. So this region of warm air, we say that region, it is the inversion layer. And in this region, the air temperature increases with an increase in altitude. Now let us continue. In summer, we are having the position of the inversion layer higher in the atmosphere. What makes the position of the inversion layer to be higher in the atmosphere in summer? Firstly, we say that in summer, like I've spoken in the previous diagram, that in summer the sun is focused in the Tropic of Cancer, in the Tropic of Capricorn, in the southern hemisphere. Therefore, the land becomes more warmer, and the air, as a result, is warmed up and starts to rise. As the air starts to rise over the land, it pushes up against the weak sinking air from the Kalahari high pressure cell. As a result, this rising air pushes the inversion layer higher in the atmosphere. Now, when it pushes the inversion layer higher in the atmosphere, now at this time, the inversion layer that is now higher in the atmosphere will allow the warm air that is coming from on top of the Indian Ocean to now be able to go over the escarpment and into the interior. When the warm air reaches the interior, it starts to rise, starts to cool down, condense, form clouds, and precipitation starts to occur. So in summer, the general conditions over the interior will be the wet conditions because the warm moist air from the Indian Ocean can now enter the interior due to the position of the inversion layer being higher in the atmosphere. Now, let us look at this other diagram when it is winter now. Now, when it is winter, it means that the sun is focused more on the northern hemisphere. And in the southern hemisphere, we are not getting direct insolation. As a result, more long nights, short days. Therefore, the land is exposed to darkness more than it is exposed to light. What does it mean? It means that the land will start to lose more heat during the night because we are experiencing long nights. So when the land loses more heat, the air that is found above the interior will also start to lose heat, becomes more dense, and starts to sink. Now, when we have this strong sinking air now, since it is winter, and we are having a weak rising air over the land because of the indirect insolation from the sun, this strong sinking air will now change the position of the inversion layer from higher in the atmosphere and brings it very close to the interior. Now, when the inversion layer is lower than the escarpment, means that the warm moist air that is coming from the Indian Ocean now is getting blocked. Therefore, this warm air, the one that is moist, the one that is needed for condensation, cannot reach the interior. When it cannot reach the land, it means that the general conditions over the land will only be from the strong sinking air. As a result, the interior remains dry with no rainfall unless we are going to have an impact from the sky, the mid-latitude cyclone, bringing a cold front that is going to bring winter rainfall to the interior. Remember, this is a winter season, and the mid-latitude cyclone plays or impacts our country in winter. So when the general conditions over the interior are dry, because the warm moist air cannot reach the interior, but now the pressure belt has pushed further high, it brings the cold front closer to the land, and cold front will now bring heavy rainfall over the interior. Only then will these conditions change from dry to wet conditions, but temporarily when we are being impacted by the cold front. Please remember that. Now, this topic is very large, guys. It's very big. And right after this, we need to understand what this diagram means, because you are having the Kalahari high pressure cell that is dominant over the land. You are having this low pressure system that moves over the coast, the one that we refer to as the coastal low. The two pressure cells, when they occur at the same time, they set up a pressure gradient. Therefore, air will move from a high pressure to a low pressure under the influence of the pressure gradient force over the mountains, down the escarpment, and undergoes adiabatic heating and forming what we call the berg winds. This is in winter. But when we are talking in summer, because the inversion layer is higher in the atmosphere, and now the warm air can now reach the interior, we are having the cold, dry air coming over the interior and the warm, moist air coming over the interior. They meet at a point, forming what we call the moisture front. They create what we call a moisture front, but now in summer. Now, collectively, these things, your moisture front, your berg winds, your coastal lows, they are referred to as traveling disturbances. This is a separate video that I'm going to post directly after this one, and we can go and learn about moisture front, the berg winds, the coastal lows in that video. But otherwise, thank you for tuning in today, and as usual, your support is appreciated. Make sure that you tune in our next video when we deal with the traveling disturbances. This is from me, Super Teacher. I'll see you in the next one. Thank you.